So first of all, good evening to everyone. We welcome all the participants and very special to Mr. Srinivas. So just a brief introduction. Mr. Srinivas is a graduate in civil engineering from NIT Warangal and a postgraduate in marine geotechnical engineering from IIT Madras. Currently, sir is pursuing a PhD from IIT Dhanbad. He is from Indian Railway Service of Engineers and has an extensive experience of about 36 years and has been associated with the iconic Chenab Bridge for more than 11 years in the construction, design, and execution of the whole project. Sir has interest in training, knowledge management, innovation, and application of artificial intelligence in civil engineering. So today we'll be having a session by Sir on Chenab Bridge about its design, construction, and concept. So we welcome you, sir, and I request you to take the session forward and share your experience and knowledge. Thank you very much, sir.
Thank you, Atendra. 1 minute, let me share this.
So screen is shared, sir. You can start your PPT now.
Now my PPT is visible.
Yes, sir. No, you have to.
Yes?
Yes, sir. Available, sir.
Yeah. Good evening, everyone. I thank Mr. Aditendra to give me an opportunity to share the excellent work done on Chenab Bridge by me and my team of engineers. And the work started with accepting a challenge, and the challenge is shown in the form of a animated film which we made at the beginning of the project way back in 2004. And this is the bridge which has been completed. It is a marvel. Now I'll be giving you a brief introduction about the bridge, then challenges and glimpse of innovations in a very short time, because the work done is for more than 15 years and it can't be presented in just 20 minutes or 25 minutes. And then what is the key factor for success that is required for future projects? And then at the end of the day, when I look back, there is a question in front of me, and I would like to answer that question. Chenab Bridge is world's highest railway bridge, and it is in Udhampur, Srinagar, Baramulla railing project. And it is Himalayas. Why Himalayas? It is young, active mountains. So the earthquakes are more and requires very special design requirements. Temperatures goes up to sub-zero, so that requires special materials to be used for the construction of the bridge. And it is very difficult to access across a deep gorge with limited access. So our construction methodologies should take care of this limited accessibility in the construction. And it is sensitive border area and also politically disturbed area. So the whole bridge has to be planned properly. While the bridge is the physical structure, but the backbone, the spirit behind the bridge is implementation of new technologies and innovations. Implementation of new technologies and innovations is not an easy thing. It is like you are trying to please your girlfriend with her favorite dish, which you don't know how to make. So what you do? First, you understand the recipe, get the best materials, and then you conduct a couple of trials, succeed. Then when she comes, you serve it, and then win her heart. This is what you have to do, and this is what has been done on Chenab Bridge. So the brief introduction of the bridge is the client is Northern Railway, contractor is Afghans, and it's undertaking. Design consultants are from Finland and Germany. Proof consultants are from UK. Slope stabilization, which is the most complex part of the project, is done in India by IISc Bangalore, IIT Delhi. Most important, you can draw any plan, anything, but execution, construction engineering is the most difficult part. That was done by Afghans in-house. And Chenab Bridge is at 125 kilometers from Jammu, and nearest location for access of 40 feet trailers is at Riasi, which is 50 kilometers away from the site. And the general arrangement of the bridge looks like this. And this is the plan, this is the elevation. And in the plan, you can see there is a transition curve in the approaches. And length of the bridge is 1315 meters, and the height is 362 meters about high flood level. So just for you to have a feel of what is the height, it can be, you can put Eiffel Tower below the bridge and still you have a clearance of 20 to 25 meters. Now, highlights of the Chenab Bridge or world's highest railway bridge. Normally in India, bridges are designed with a life of 50 years or 100 years. We are designed for 120 years. The deck is launched incrementally on a combined circular and transition curve for the first time in the world. And we have installed world's largest capacity crossbar cable crane for the erection of piers, trestles, and arch segments. We have done extensive wind tunnel testing because this bridge is across a gorge, and this has been done for the first time in the world, in India. And we have done fatigue design and detailing of the bridge. That is also for the first time in India, and it's a marvelous work. And we have used double corrosion protected bar and cable anchors for ground support for the first time in India. And we have used the highest diameter and highest grade high strength friction grip bolts with geometric coating in this project. And normally bridges are never designed for blast loads. Because this bridge is close to Pakistan border, we designed the bridge for blast loads. And special considerations in the design, because it is in Himalayas, so we have used special structural steel because it is in sub-zero temperatures and seismically active area. So we got site-specific response spectrum developed, and we carried out dynamic analysis of the structure, and we did the ductile detailing. Because of the poor geological conditions, we have done extensive investigations and done extensive slope stability analysis. Because wind speeds are high, we have done wind tunnel tests and then designed the bridge according to that. Sensitive border area, the bridge is designed for redundancy. What is redundancy? This is the arch. Even if you remove one member, the arch will not collapse. And similarly, even if one diagonal member is removed, the bridge will not collapse. That is how the bridge shape and structural arrangement has been made to make sure that entire thing works well. And even if these members are removed, still you can carry traffic on the bridge with a limited speed. Then what is incremental launching? So this is the bridge. I'm talking about this portion, and there is a transition curve here. This is straight portion, and there is a transition curve. Then there is a circular curve. So world over, incremental launching is done either on a straight portion or on a curve of uniform radius. So, but in this project, we have done by using a very innovative technique and did the launching for the first time in the world on a combined circular and transition curve. The principle is very simple. The deck is fabricated as per the bridge alignment. See, this is circular curve, blue curve, and magenta. These two colors indicate the original bridge, and this has been fabricated like this only, but it is launched from this point to this point on a hypothetical launching circular curve of different radius. Then the question is how to decide this hypothetical launching curve. So when you are trying to move, the deck tries to move laterally. So this distance x and this distance y should be more or less equal. So we followed this and we have done it. And the proof of pudding is in its eating. So this is what the bridge looks like, combined circular and transition curve, which was done incrementally launched. Fitting design, yes, is the best part of the design I like. And the design of the scallop around the secondary beam is very innovative. See, whenever there is an opening, in a steel girder at the load carrying member, there will be stress concentration. That concentration will lead to fatigue cracks. There are two options: you go for a thicker plate or you work on the geometry of the opening. We have done by trial and error, we developed this very odd shape of the scallop, and thereby we minimized the we have optimized the design. And in for achieving this type of cutting of the scallops, we have used CNC controlled cutting machines, and this is how this has been done. Slope stabilization. This is the slope on the left bank before we start the work. If you look at it, people will think you can't even put the foot how you do the work. The excavation is something like 6.3 lakh cubic meters. Rock bolting is 33 kilometers. Shotcreting 54,000 square meters. Davidoff bar installation is something like 4,000 or 4 kilometers. So all this work has to be done, ensuring safety. And the muck should not fall in the river. It's not that I excavate and dump everything in the river. No, that is not permitted. So the work has been completed very systematically. And design of slopes is one big job, and the execution of work is another job. This is the work we have done from first principles. And in fact, my PhD work is on design of jointed rock mass slopes in highly jointed rock mass. So what we did, one is, if you see in the initial stages, we developed the approach roads so that the muck can be transported properly, whatever is excavated. And this is how, when we have completed, it looks like, with approach roads and stabilized slopes. Like I told, construction is also very important. We used top-down method of construction. So we started from the highest point and started excavating as we move forward. So this green portion is the work completed and stabilized. The violet portion is the work in progress. So like this we have done. And working with contours, working as per contours, that concept is not just limited to citizenries. Today, my son works in the area of artificial intelligence. And when he talks about logistic regression, and he talks about contours and contour gradients. So this is the finished slope, and the arch foundation is completed, arch erection in progress. This is on the left bank. This is the one on the right bank. Right bank is relatively on a weak strata, so it was having extensive prestressed cable and bar anchors. This strata is very bad, and there are loose pockets, open joints in the rock. In fact, if you remove these boulders, this person can go inside and stay there comfortably. So this is how this strata was. So it has been decided to grout entire strata, and we have done grouting, and we pumped almost something like 5.5 lakhs of cement bags for grouting this strata below the foundations. So one proof is, you see when you take the core, you see the cement slurry. And if you see the excavated rock mass, this is all your cement. So this cement has filled up and improved the strength of the rock. While this is a pictorial representation, we also have done testing by multi-channel analysis of spectral waves. If you see that this was the thing before we started the excavation, consolidation grouting. You see there are a lot of loose pockets. And after completion of the consolidation grouting, you see practically everything is in layers. That means very stable strata. And the elastic modulus has improved by almost 200 to 600% after consolidation grouting. So that means very solid foundation has been provided for arch as well as other foundations. Now, what is the delivery quality? So let us talk about pier erection. The height of the pier is 145 meters at S40. On the top of the pier, what is the tolerance? So the tolerance is what we achieved is 23 mm and 14 mm, whereas the permissible error in tolerance is 100 mm in any direction. So these figures speak for the quality of work. And it is not that we achieved at the top. Everything has to come in the fabrication of the equipment, fabrication of the components, assembly of the components, everything. And similarly, when you want to do arch erection before closure, these are some of the photographs of the joints of the arch in the sky. And all these bolts are perfectly matched. We did not drill even a single bolt hole, re-drilled, or we have not done gasket. They met perfectly like a Lego toy. And I would like to say one very important thing. What we did was, you pick up any bolt. There are something like 2 lakh bolts used in arch and 3 lakh bolts used in the project. You pick up any bolt anywhere in the structure, we can trace it back to its manufacturer test certificates. That is, we can locate complete traceability of whatever work done has been established in the project. So with this type of work, when we did, and the arch closure just before we want to close, the tolerances are 39 mm and 22 mm and 15 mm and 12 mm, whereas permitted tolerances are 100 to 50 and 100 mm. And this did not happen overnight. See, arch top is about 120 meters above the base of the arch and 250 meters away from the arch. With that, when we joined pieces one by one, and came to this level, this is the precision we have achieved. And how that was achieved? So the lot of care has been taken at the base of the arch. This is the base of the arch, which receives here. And if you look at this, this is my most beautiful picture in this project is this. I call this as javelin reinforcement. Every reinforcement bar is of different length. So for example, this bar is of different length, this bar is of different length, this bar is of different length, this bar is different. So all bars are of different length. It is like you are making a jewelry instead of gold in reinforcement. This has been done flawlessly. And then after that we concreted, and now I have to seat this base module. If there is an error in the geometry of the base module, it will affect the tolerances at the top of the arch. So there are no guidelines provided for us on what is the tolerances to be achieved. We put a self-imposed tolerance of 5 millimeters, and we wanted to ensure at 12 points on the base and XYZ, it is only in one of the things, there are 4 bases, of which three, they're all within 5 millimeters, and only one we could not achieve 5 accuracy. And after struggling for 2.5 days, we thought, okay, enough is enough. We'll handle whenever the problem comes. So, but when at the end of 2.5 days also, we are talking a figure of -7 and -6 against -5 values. And this is all led to such a beautiful work. Now, most important thing, erection of the arch is how do you lift the components? You look at this component, it is coming almost parallel to the surface where it has to come. So there is an element, not a very simple element of engineering on how to lift the components so they come at the required angle. So all that has been done. So arch base has been installed, and then the gaps have been closed using multi-metal compound, and then arch has been erected. For the erection of the arch, we have installed world's largest crossbar cable crane, which has a capacity of 34 metric tons on single hook, and individual capacity of each bar is 20 tons. And for the arch erection, so since the capacity is limited to 34, component of each arch member should be less than 34 tons. And there are 1,375 components to be erected. And this cable crane is something like 128 meters. Now, how do we erect this cable crane? So we have gone for a very simple thing. There is a movie called Cliffhanger, where Sylvester Stallone tries to climb the cliffs. What he does, he drives nail on or peg one level above, hold that, climb up, and then install another nail or peg and move up. Same thing has been done in this project also. So the first part of the cable crane has been installed with the help of a tower crane, which is around 50 meters. Then we have installed two what is called climbing cranes. These climbing cranes will erect one module and hold it, then move up, then install the other module. And these climbing cranes have been designed indigenously. Now you see in this figure, the climbing crane is at the level of horizontal member. The next figure, you see one module has been erected and the climbing crane has moved up. So like this has been completed. This is how the one pylon of one side has been completed. Likewise, all four pylons have been completed. Now, after all the four pylons have been completed, now the question is, how do you put cables on the top of it? If you ask today our young engineers, they will say we'll use helicopter and do it. But we have done something different. We did not use helicopters. We used simple balls. These are all the fabricated steel balls, and these are connected to winch on either side of the river. Then we drop it from both sides and then send a person on a boat. He joined both the ropes and bring back the balls. Now what happens, there is a continuous rope available from one bank to the other bank. Then, so we started with a 12 rope, then 18 rope, then 36 rope connected, and finally pulled all the cables. So then once entire 58 cable is from one side to the other side, then we just simply used the climbing crane and install the cables. That's all. This is all the simple innovative work has been done. And innovation is very simple. Yeah, for first time it is difficult. And once it is done, anybody can do it. So this is the cable crane commissioned in the month of July 2013. And this has been used extensively for the erection of the arch and piers. And in all this work, there's not even a single untoward incident. And normally, Safety Council of India gives safety award. Normally, they give Visishta Suraksha Puraskar, but they thought Chenab deserves even something bigger than Visishta. So they have given Ati Visishta Seva Puraskar for Chenab Bridge in the year 2019. That is how we transformed a challenge into a marvel. Now, the question, how is the challenge transformed to marvel? What is the key factor for success? The answer is everybody looked at Chenab Bridge as a temple of new age. So when you go to temple, whatever you do with utmost devotion. So on Chenab Bridge, every action was performed with utmost devotion. And now, at the end, there is a question in front of me. Many people ask me. The question is, what was your expertise to work on this project and going forward? Are you a permanent work designer? Do you do temporary work designs? Do you do construction engineering, contract management, project management? So this is a question everybody will ask me. But my answer is simple. My expertise is work from first principles. If you are working in an uncharted area and on new emerging technologies and new areas of work, you should have strong grounding on the first principles, and you should work from known to the unknown. Even that is what is enshrined in our Vedic textbooks also. Now, I got this grounding on working from first principles from during my training in IRSC, Indian Railway Service of Engineers. And whatever new things we wanted to do, AFCONs generally allowed me to try whatever is required, and we have done. And now the work speaks what has been done. Thank you. Any questions? You are welcome.